Welcome back in this new video in our masterclass in project management. And in this video, I'm going to explain how we can use PERT or the 3-point estimates and link it to risk management. We will be looking at the 3-point estimates, and we know there are two types of 3-point estimates we can use. We have the PERT and the 3-point, what we call the 3-point, and we look at the different steps to follow. Then we look at the PERT and the 3-point estimates with some formulas and some examples. Then we have a project example step by step, the PERT and the 3-point probability graph, and the PERT and the 3-point probability graph when we are considering the near critical path. Let's have a look at PERT and 3-point and the different steps to follow. We determine first the optimistic, probable, and pessimistic duration for each task. What are the steps to follow? First, we calculate the duration and standard deviation with the PERT values. We look either at a beta distribution or a triangular distribution. When we use the beta distribution, we call it the PERT estimate, and with a triangular estimation, we refer to it as a 3-point estimate. We calculate the variances of the activities on the different paths. We look at the path variance, which is the sum of the variances of all tasks on that specific path. We calculate the standard deviation from the variance, and for those who forgot it, the standard deviation is obtained by taking the square root from the variance. Then we calculate the z-score for different durations, and we draw the S-curve. Let's have a look at the PERT and 3-point estimates. We're looking at the formulas and an example. We have an optimistic estimate of 45, for example 45 minutes to go from A to B. A probable estimate of 90. Probable is also the mode, the event or the duration with the highest probability. And then the pessimistic estimate is 145 minutes, where everything basically is going wrong. Then we have the PERT formula. So the expected duration is 45 plus 4 times the optimistic estimate, 90, plus 145, and we divide by 6, which gives us an expected duration of 91.7. The standard deviation is 145 minus 45 divided by 6 is 16.7. We can do the same for the 3-point formula. Then we have the expected duration, meaning we just take the normal average, so 45 plus 90 plus 145 divided by 3 gives us an expected duration of 93.3, and the standard deviation is 145 minus 45 divided by 5 is 20. And we see in both cases that the expected duration, when we take the 3-point estimate, is higher than the PERT estimate. And this is based on the fact that we have, when we calculate the 3-point, we don't know so much about the probability distribution of the activity durations, and we have a higher value and also a higher standard deviation or a higher variance. Now we can do this on a project. We have a project example here. I have here 6 activities, A up to F, and the first number of the activity is the expected duration of that activity, let's say periods or days, and the second number is the standard deviation. So based on this, we have 3 paths, ADF, BDF, and CEF. And we can identify those 3 paths, and we can calculate the duration of those 3 paths. And what we see is that we have one path which has a duration of 21, which is the critical path. Next thing is to calculate the standard deviation of the critical path. And what we have to do, we want to calculate the standard deviation for the path BDF, and first we have to calculate the variance. So the variance is 2 to the square, plus 1 to the square, plus 2 to the square, which gives us 9. So to get the standard deviation of the path BDF, we take the square root of 9, which is equal to 3. And what we're going to do now is look at different durations. I took a step of 1 standard deviation because that's the easiest one to do. We can, for the table, to make the table, you can take any dates that you want. If you want to make a nice drawing, you have to have a lot of intermediate numbers or durations. So for the duration of 21, that's on the average. In that case, the standard deviation is 0, and there is a 50% probability that the project will be finished in 21 periods or less, or 21 periods or more. Then we add 1 standard deviation, so 24, is plus 1, and we find 84 plus 13%. In the same direction, or in the same principles, we deduct 1 standard deviation, so 21 minus 18 gives a z value of minus 1, and we find 15.87%. We know that the surface between average and 1 standard deviation is approximately 34%. Then we have those different steps that are well known for the normal distribution. So now we see, when we look at this curve, we see that there is a probability of 0.13% that the project will be finished in less than 12 days, 2.28% less than 15 days, 15.87% in less than 18 days, 84.13% in less than 24 days, 97.72% in less than 27 days, and 99.87% in less than 30 days. So with this information, we have a clear overview of the link between duration and probability, and that's a very interesting element to share when you're talking with your management or with your sponsors or with other stakeholders. We can draw this in a graph. We can draw this graph, so we have this basic information to create a graph, and we see the 3 paths. We see BDF is the critical path, the orange is CEF, and the dark green is ADF. And it's clearly visible here that the red line is in fact showing the relationship between duration and probability. The other lines don't intersect, so this is a clear case. The near critical path has no effect on this graph. But when we look at the near critical path, and what can happen with the near critical path is that the standard deviation can change. And when the standard deviation becomes larger than the standard deviation of the critical path, that probability curve goes flat. And you see that from approximately 23 periods, the critical path is not determined by BDF, but is CEF. And that's one of the disadvantages of the PERT and the 3-point estimates, because we're only looking at the critical path. We should have a look at the near critical path, but it's an easy method to follow, and until now it still has gotten us a lot of very good results, but it's always possible to do better. So that was it for this presentation about PERT and applying it on a project. So that's it. Thank you for watching, and I'm looking forward to seeing you in our next videos. Bye bye.